Okay, Assalamu alaikum and Salam Jatra. We'll be discussing chapter 3 today, Traverse Survey. So before we proceed, let us have a look. What does traverse mean? Okay, if we look at the dictionary, a simple definition of traverse is basically travel across or travel through. So what does that mean? That means when we do this survey, it will involve moving from one point to another, and while we're moving, we have to do measurements. So traverse is basically going from one point to another and doing some kind of measurements that we require at the end of the day. Okay then. Let's start with a bit of introduction. If you recollect, in chapter 1, we have discussed about the basic principles of surveying. And if you realize number 2, the second principle is from the whole to the parts, which basically means before we could start doing any survey work, we have to have controls. We have to provide controls. And in chapter 2, we've learned how to provide vertical control by establishing points with radius level. And in this chapter, in Traverse Survey, we'll be looking at how to provide the horizontal values for those controls. In other words, we are looking at the coordinates in the horizontal plane. Okay, and also, if you remember, apart from traverse, there are several methods that we could employ in surveying. The basics method, which I named them as trilateration, intersection, and resection, but we are not going to look that into detail. We will be looking at traverse because that is the most common method used in establishing horizontal control. Okay, now what we have on the screen is basically to explain what traverse is and what it is used for. Okay, we could start with the first point here. At the top it says establishing the positions of a series of linked points. So the keyword there is linked, which means that the points that we are establishing are linked with one another. And how are they linked by? They are linked by bearing and distances. Okay, so imagine a series of points, and all those points will have values of bearings and distances, the line joining them. Okay, now when we talk about bearing, okay, when we do measurements in traverse, there are basically two types of ways, or two methodologies, or two approaches that we could approach, or two conventions that we could use. Is either we're going to work with a whole circle bearing, which runs from 0 to 360, a complete circle, or if you like, some people do, to use what they term as quadrant bearings. It runs from 0 to 90 degrees, according to the quadrant where you are in. So north 45 degree west, well, simply means the quadrant northwest is 45 degrees from north. Okay, so having gotten the bearing and distances of these points, what we'll get at the end will be positions. And how do we get the positions? In this case, I've written down northing and easting, okay, which basically means y and x. Okay, we'll get into that later. Okay, but the thing is, the value that we observe, okay, the bearing and distances, just need a simple trigonometry calculations to provide us with that, noting the things that we want. So there's no high-level computation involved, just the basics trigonometry, which I'm sure you are used to. Okay, and why do we need traverse? What are they used for? Well, the established station, the station that we have just measured and established the coordinates, will be used as control points, as I said earlier. For what? For mapping and setting out jobs. Okay, so again, if you look at the concept from the whole to the parts, the points or the stations or the traverse points provide the parts, sorry, the whole, I mean, and from there on, okay, any subsequent measurement will be referred to the whole, which is the traverse station that we have just established. And traverse basically are divided into two types. We are either looking at the closed traverse or the open traverse. Okay? Similar to what we have learned in leveling, a closed simply means that you could do checks. You could check your errors, you could check your accuracy, whether you have reached the minimum standard. And open simply means that there's no check that we can perform, and we cannot be sure that what we have calculated is the most probable value or the correct value, if I can say that. Okay, we'll get into that in detail. So that is basically just to explain what we're looking at. Okay, the things that we're going to be observing, the measurements and the calculation, a little bit on the calculations and the characteristic of the traverse themselves. Okay, if you look now on the screen, you have I've drawn a point B, okay, on the top left corner, with coordinates x, b, and y, b, similar to your exercises when we do mathematics. Okay, supposing there's a point B with known values, the coordinates are known, given to us, x, b, and y, b, and at the same time at the bottom of the screen there's another point, point C, whose coordinates are not known, x, c, and y, c. So the idea now is to determine the coordinate of C based on what we have at B. At the moment we have the coordinates of B, x, b, and y, b. So if I were to measure the distance from B to C, okay, let's call it S, and measure the angle at B to C, okay, and if you look from there, if you look on the screen, the angle is measured from north, meaning that B is a bearing. Okay, it's not any ordinary angle, it's a bearing, because we refer the zero from north. Okay, now let's call it beta, okay, bearing. So if, okay, I'm going to use some simple trigonometry, I calculate the vertical distance along the north axis, or the y-axis if you like it, and I'll do the same thing on the easting or on the x-axis. So I will obtain another value, s sine beta. So that simply means that the coordinate of C is given by wherever that we have at B, plus the differences in northing and the differences in easting. So that's basically what we are doing in traversing. We measure bearing, we measure distance, we can obtain the coordinate of, we can call C as a forward point or forward station, if you like, right? Now, imagine that we'll be doing this in a series, okay, like what is shown on the screen now. Okay, we started the work at 1, then we'll go to 2. When we're done at 2, measure angle at 2, we get 3, move to 3, 4, and so on to 7. So this is what we call a traverse, and in this case it contains 7 stations. So a traverse that contains 7 stations. And note that, okay, bearings are measured, okay, from at each point, and bearings are measured, of course, clockwise. So bearings runs 0 from the north, 360 clockwise. Okay, so that's how bearings are measured in traversing. Okay, so imagine that you got all the bearings and all the distances. If you are given x and y of 1, okay, of this point 1, there shouldn't be any problem to calculate 2, and therefore 3, and subsequently 4, 5, 6, and the rest of the stations in the traverse link, okay, or in the traverse system. Okay, so that's to give you an idea what traversing means. So it means moving along or going through. So it will involve a fair bit of walking, okay, obviously, and just establishing points in the ground and measure the angles and bearing between them. Okay, now so we know that we're going to measure angles. Okay, we know that we're going to measure distances, and I think by now you can accept that when we say measuring, we just not simply mean measure, but we have to look at accuracy. We have to look at what are the errors. Okay, so obviously the equipment could be quite substantial, but let us look at what are the basic equipments that we need to do a traverse, to perform a traverse survey. Obviously, we're going to need an angle measuring equipment. Okay, they are called theodolites. Okay? Theodolites are basically angle measuring equipments, and it's quite precise. Okay, and a few examples that we can look at. I think the first one we have here is what we call as a Vernier Theodolite. Okay. It's called Vernier simply because the scale that you read there is of a Vernier scale. So any angles that you read will be from a Vernier scale, hence the name Vernier Theodolite. Okay, then we'll have other types. Okay, the next one that are in the middle of the screen, this is called optical. Okay, again, it's differentiated by the way the readings are given. Okay, in this case, the angle is read through a telescope, which gives you the degree, the minute, and second. So there's no vernier anymore. Okay, it's akin to a micrometer, okay? Like reading a micrometer, but not exactly, but something similar. Okay, and then obviously now things have gone digital, advancement in technology, so which means that we do now have digital theodolite. Okay, simply because angles are now given on a screen, normally on a LED screen. Okay, that gives you either the vertical angle V or the horizontal angle H. Okay, and obviously with a digital theodolite you need some kind of power. So in this case you put a battery in there. I think this one runs on a normal standard AA size batteries. Okay, so that's angle measuring equipment, so theodolite. Okay, and we also have to measure distance. We mentioned that earlier. So several ways. Simplest way will be using a steel tape. Okay, It's actually made of steel, and it's 20-meter long. And if you look at the screen now, there are two rails. That one is graduated, 20-meter long. That one is not graduated, also 20-meter long, but there'll be like a couple of tapes in there. So let's say you're measuring a distance of 45 meters. You'll need two of this, which is 40 meters. Then you're going to plus 5 meters from that. So that's how you use them. You got to use them together. Okay. So that's using steel tape. Okay. And some textbook they term as catenary taping. Okay, catenary taping. But for now, just call it steel tapes. And at the same time, we've got fiberglass tape that you're used to, and that you normally do. Okay. Again, graduated to the nearest millimeter, if I'm not mistaken. Yeah. Okay. It's a direct measurement. You have to physically go in and measure them. Okay. Go to the 2 points that you're going to measure. And again, with technology, with electronics, we do have what we call an EDM, which stands for electronic distance meter. It's basically an instrument, a device that you put on top of a theodolite. You mount it on top of a theodolite, and to use an EDM, you need at the other end, the point that you're measuring, a reflector, or sometimes called a prism. Okay, prism or reflector. Okay, so that has to be used in together. Okay, so we'll discuss that in detail in coming slides. But for now, distance measuring, you can either go a simple way using tapes, or you could go the electronic way using what we call EDMs. Okay, but however, advances in technology in electronics, okay, have made changes into the equipment that we use. Okay, we used to have this, a theodolite and an EDM to do our traverse work, but now those two equipment are combined to produce just a single equipment like that, which is called a total station. So a total station is basically a theodolite plus an EDM built together, okay, integrated. So obviously, if you look at the panel down here, total station has more functions and more interaction with the user. Okay, all right, and you will be using total station in your work, because to keep up with technology, I think it's appropriate that you'll be using total stations rather than a theodolite and an EDM, even though we do have them. Okay, all right. These are images to show different types of, different makers, different brands of total stations. And we've got Leica on the left, which is a Swiss made. Okay, that one there. And the Topcon, that's a Topcon, that's a Sokia. Those are both Japanese. Might look a bit different, slightly different though, but it has the basic features, the same features: a panel, buttons for inputting data, a telescope, EDM inside. So if you are familiar with any one of them, there shouldn't be any problem with familiarizing yourself with another brand or another equipment, because they've got the same basic functions. Okay, now
انضم معنا الآن واشترك بالقناة ليصلك كل جديد. YSAG، معا نحو مستقبل مشرق.